So now this gets us into Dalton's law. It's Dalton's law of partial pressures and mixture of gases, right? And we've just been talking about that, right? For example, Dalton's law says if I have some container, and I love drawing balloons, right? So suppose I've got a balloon, and in this balloon are a whole bunch of gases, okay? So I'll say P tote, okay? The total pressure inside this balloon is going to be the sum of all of the individual pressures of whatever is in there, okay? So for example, suppose we put atmosphere in the balloon, right? Which could be achieved like through a pump. Not me like blowing it up, like putting my breath, but let's say I'm putting the actual atmosphere in the balloon with some bike pump, right? Pump it up, okay? Well, that total pressure would be, let's just call it, 1.00 atm, assuming we're at sea level and it's perfect conditions, okay? Well, as it turns out, about zero, actually I'm going to take one significant digit off because I just realized I don't have all of these digits committed to memory. 1.00, okay? Well, as it turns out, nitrogen would account for about 0.78 of that at sea level, at the atmosphere. At sea level, nitrogen is about 0.78 atmospheres, okay? Oxygen is about 0.21 atmospheres. This plus this gives me 0.99. All of the other stuff in the atmosphere, the argon, the carbon dioxide, the water, all that other stuff contributes about 0.01, okay? And so we could, that's why I took away one significant digit, right? If I had 3 sig figs, then I would actually start to see more precise numbers for all of these other things, okay? But in any event, the pressure that we get in the case of the atmosphere, for example, is a sum of the pressure of all the other individual components. And this is actually where you get the average molar mass of air, okay? From the fact that about 0.78 is nitrogen, about 0.21 is oxygen, and about 0.01 is all this other stuff, okay? And so there becomes a really easy way to use these numbers in calculations. And that's called the mole fraction.